This is our last part of this three-part series on water, and we're going to pick up right where we left off from our second video. So in our second video, we were talking about how water can disassociate, and when it disassociates, here we are, it can form hydroxide and hydrogen ions. And so hydroxide has a negative charge, hydrogen atoms have a positive charge. So this disassociation, when it occurs, we are going to have equal concentrations of hydrogen and hydroxide, which is 10 to the negative 7 moles per liter. So the product of the concentrations of hydroxide ions and hydrogen ions in pure water is 10 to the negative 14th. And so this equation then shows us a little bit about the relationship between hydroxide and hydrogen ions. What we can see is if we have a constant and we increase the amount of hydrogen ions, we know that the amount of hydroxide has to decrease. Conversely, if the amount of hydroxide ions increase, to have our constant be the same, the amount of hydrogen ions in the solution would have to decrease. A better way to look at this is in a graph. So here we can see is pH. Most people are familiar with pH. So pH is a measure of the concentration of hydrogen ions in a solution. And a neutral pH is a pH of 7. So at a pH of 7, we have an equal amount of hydrogen and hydroxide concentration. So that's our 10 to the negative 7th. All right. If the amount of hydrogen ions increases, we have to have a decrease in the amount of hydroxide. Conversely, if hydroxide ions increase, we have to have a decrease in the amount of hydrogen ion concentration because of our constant here. As we go through, you're going to see that hydrogen ions, as their concentrations increase, that corresponds to a decrease in the pH scale. And as hydroxide ions increase, we see an increase in the pH scale. So pH is there to allow us to easily measure the amount of hydrogen ions in a solution. And so acidic solutions have a high concentration of hydrogen ions, so greater than 10 to the negative 7th. And basic solutions have a lower concentration of hydrogen ions, so they have below 10 to the negative 7 hydrogen ions. So acids are acidic, and by definition, an acid is a molecule that can add hydrogen ions to a solution. So as we increase in the number of hydrogen ions, we decrease in our or on our pH scale. And so any substance that can increase the concentration of hydrogen ions in a solution is an acid. So strong acids, all of the molecules are going to disassociate when they're placed in a solution. So one of the strongest acids that we have is hydrochloric acid. Hydrochloric acid, that also makes or is the same as your stomach acid. And so when it's put in a solution, all of the hydrogen ions are going to disassociate from the chloride ions. And as they do, we will increase the amount of hydrogen ions in that solution, and then our pH will decrease. If we had a weak acid, only some of the molecules would disassociate, and so in the end we would only have a few disassociated ions, so we would have a smaller increase in the amount of hydrogen ions, and so we would have less movement on our pH scale. Base is the opposite. So a base is a substance that can remove or accept hydrogen ions from the concentration. And so molecules that do that are considered to be alkaline or basic. And what you can see is bases, as they remove hydrogen ions from the solution, we would be measuring fewer and fewer and fewer hydrogen ions. And as we do that, our pH scale actually increases. And so here you can see is a base, sodium hydroxide. So as sodium hydroxide dissociates into its sodium and its hydroxide ion, this hydroxide ion can actually go scavenge and accept or bind up any excess hydrogen in the solution. So as it does, you can see here's hydrogen. As our hydroxide ion binds this hydrogen, it will form water. And so our bases are alkaline. They can neutralize acids and make them more basic.